Hello and welcome everybody to Today in Space. I am Alex Girofanos, your space science podcast host from the East Coast, and we're back for another episode of Today in Space. It is today, we're recording this on June 8th. If you're new to the podcast, my name is Alex Girofanos. I'm an engineer, maker, podcaster, and I'm here to talk about all things space because that's what I'm extremely passionate about. 3D printing as well, which if you haven't already listened to our last episode with Jane Davies, where we literally talked about just that, the cross-section of 3D printing, space, and humanity. That's kind of the other topic here. So we're here to talk about all things space. Thank you for joining us. We've got a lot to cover here. So I'll give you a quick review, and then we'll start getting into stuff here. We have a lot of James Webb Space Telescope updates. We have an actual date, a hard date, for the actual reveal of the first actual images that James Webb has taken while it's out there at Lagrange Point 2, orbiting around the sun. And that's going to be amazing. I can't wait for that. We also had some interesting news about what happened back on May 23rd and 25th. Luckily, it apparently hasn't affected James Webb Space Telescope. We'll talk about that. And I was lucky enough to join another Twitter Spaces where the NASA James Webb Space Telescope team was discussing and answering questions about James Webb Space Telescope. And I got to ask a question about that, and it was really cool because it kind of set up these chain of questions following up afterwards, and we've got a really cool clip at the end of the podcast, so we'll close out with that. It was really, really cool, and if I'm not mistaken, I think the NASA Twitter account waved at me when I was asking my question, which was mind-blowing. So, yeah, crazy. So some really cool stuff is happening around a very crazy world. But that's just in astronomy and deep space for James Webb Space Telescope. We also have some updates from the AG3D lab, which we'll talk about in a second here. There were two big stories that happened in May. They actually got released on the same day, May 12th, where we found out that moon soil plants, so literally plants that were grown on Earth with soil from the moon that was taken during the Apollo era, grew plants. So we got to talk about that because that's insane. And then at the same time, we also got the first picture of the black hole at the center of the Milky Way galaxy, Sagittarius A. And there's just some numbers behind that I have to bring up just to show you the scale of that. It's also crazy because that's only the second image of a black hole that we've ever had. And it's the first time we've actually proven that our galaxy has a black hole at the center of it. It was theoretical. Einstein always thought it could happen. The math seemed to play it out. We put a telescope. We pointed it the right time we saw it. So there's some crazy stuff going on there. And then we'll also follow up with a little bit of talk about Blue Origin's latest launch. So without further ado, let's start the show. All right, so before we start, we have to talk about what funds this podcast, the fuel, the source behind what brings this podcast out to you every single week, and that is our 3D printing lab, AG3D. And AG3D is here to help bring not only our own ideas into reality, which is literally what it's doing with this podcast, putting it on its shoulders, putting the team on its back, but it also allows us to make a lot of fun stuff for the podcast. Like, for instance, right here is our James Webb Space Telescope coaster. We designed this, we 3D print this, and we actually 3D print these on demand in our Etsy shop at ag3dprinting.etsy.com. That's the best way that you can help support this podcast if you want to. And the cool thing is you also get something cool in return. So we're literally making our own merch, and it's something cool that you can have and use around the house. And if you have any ideas of what you'd like us to 3D print, obviously reach out to us. You can do that. Follow us on AG3D Printing at Instagram. It's probably the best place. And then, of course, we also offer 3D printing services. You know, we are a shop that's open. So if you do need 3D printing, if you want something 3D printed, let's say you're a student in college, you've got a project. I guess it's the end of the year now, so maybe not. But let's just say you are a student and your lab is busy and it's crazy project time and you want to 3D print something, but everything's busy or all the printers are down. We're here for you. If you're someone, you've got an idea, like our friends at SnapCollar, we help them design some of the first prototypes so that they could see, we have this idea of a business we want to do, of a problem we want to solve. Let's make a prototype and then go to the next step with it. they did that with us. We helped them design, and eventually they iterated to the point where they were able to win some competitions, get some money, some funding for those early days, and now they had a successful campaign. They raised a bunch of money, and now they are a business. They're growing, and it's so cool to see the final product out there and actually helping people, and it's doing such a great job. We help people with that, but also just like if you want to 3D print anything, man, like we are here. Our Instagram page is a place you can go to see what's possible. I seemingly can't help myself but 3D print things all the time. So all the 3D printer did was make all the things that I wanted to make up here actually possible. I've been doing this for a really long time, so I think a lot of people with 3D printing get a little scared because it's really intimidating, but we're here to help bring your ideas into reality and help you achieve the thing. Literally make it so that whatever you're writing on paper, on a napkin, that something, whatever it might be, we're here to let you know how we can do it, and if not, we'll point you in the right direction of the right way to go. So if you're interested, reach out to us at ag3d-printing.com. You can get a free quote for your next project. And then, of course, we support the podcast at any time by going to our Etsy store, ag3dprinting.etsy.com, and picking up any of the cool stuff that we have here, like the James Webb Space Telescope coaster. We also have our rocket ship phone stand, which is great for any office space. I literally have one at every desk that I have at home, at work. Super helpful, and that's what we're about. So AG3D printing, bringing ideas into reality, and bringing the show to all the masses. So that's what helps bring this show to you. Let's start talking a little bit about some space here. So to start, let's talk about the Blue Origin mission. So Blue Origin, I'm going to pull up the article here, and all the articles of the things that we talk about on any episode, we will add that there so that you can do your more research, you can follow up. We're just trying to get you talk about the most interesting stuff from our perspective, in the hopes that you will then dive deeper and look more into it, whatever it is that interests you. So always know that in the description of any show from us, you should see those. So NS-21 was the mission that flew 6 customer astronauts to the edge of the Kármán line. The Kármán line, for those that are new, is the edge, the defined edge of space. Not that we really know what the true edge of space is from Earth to now I'm in space, but this is the rough number that we give. So what the Blue Origin New Shepard rocket does is it flies people up in the New Shepard rocket, the capsule releases, people spend some time at the top of that parabola in 0G, right above the Kármán line, and they come back down, the booster lands and is reusable, and then the capsule lands by parachute. So they did that, and that was really interesting. There were 6 astronauts. There was astronaut Evan Dick, Katya Echazarreta, Hamish Harding, Victor Correa Hispana, Jason Robinson, and Victor Vescovo, the 6 astronauts that were on board. I think the most interesting story to me was Katya Echazarreta, who I actually started following her. She has a bunch of stuff that she does in STEM, and she was doing electrical engineering, and she had this amazing lab that she had set up where she filmed a lot of her stuff. I was really jealous of the lab. It was really clean and organized. It was really nice. But it was really cool what I liked what she was doing, and she's on a mission to increase representation of women and minorities in STEM. And if you want to follow Kat, she's at Kat Voltage on Instagram. That story to me, you know, she's the first Mexican-born woman in space, and yeah, I think she might be one of the youngest women to go to space as well. And just seeing her face on some of the footage after the mission happened, of her actually like experiencing 0G, I thought was really cool. But I find it interesting, you know, we're at this weird point with the Blue Origin launches where, you know, they are doing an amazing thing, which is sending people to the edge of space and back. It's something that now any citizen can do, right? Kat is now able to do this because of this type of thing that's available. That's not necessarily something that SpaceX is doing at a large scale. They have done it with the Inspiration 4. That was the first all-civilian mission to space. It didn't even go to the International Space Station. It had a very an orbit that was higher in altitude than the International Space Station. So we actually got farther from Earth. But that was a very special mission, where I think Blue Origin's mission with New Shepard is to make things regular and normal and something that's expected. Like, yeah, anyone can go to space. Now, granted, the cost of these trips are out of the range of most people, and I believe Kat had the opportunity where she was actually sponsored by an organization to go up, and I think that's awesome. The interesting thing is the challenge that Blue Origin has to get these missions as often as they want to fly them, because, NS-21, they've already flown multiple times. They've flown people to space. I think it does get some traction in popular culture, and I think they are getting people talking. Obviously, talking about sending people like Pete Davidson. Those type of things help get into the pop culture. But I'm definitely seeing a point. Like, if you're going to talk about people going to space, you should be talking about and promoting Kat. Like, she should be the one that the stories are being written about, how, she was the breadwinner for her family at 18 and worked all the way up to this point where not only was she empowering other people in STEM and electrical engineering, and she was a science show host, she also then became the first Mexican-born woman in space. Like, talk about a missed opportunity of a story that really I think we'd all like to hear with all the travesty that's going around in the world. These are the good things that should be promoted more. But I'm interested what you guys think, because I know there is a divide on how popular these Blue Origin launches are, and whether or not we've talked a lot on Instagram, Today in Space Pod, if you guys want to follow along and join in. I know a lot of the times when we discuss these things, people talk about how, going up in a capsule's not really, if I'm going to go to space, that's not the way that I would like to go to space. I want to go to deep space. I want to go to the moon. I want to go to Mars. But I'm interested what you guys think. How do these missions, did you even know this mission happened, first of all? And second of all, what do you find interesting about them? And do you think these are as exciting as a SpaceX launch, as a Rocket Lab launch, as a NASA launch? I'd like to know how it ranks in your list of space things that are going on. But a big congratulations to Katya and all the people who launched on NS-21 and came back safely. Blue Origin's safety record so far has been pretty flawless. So I think by the time that they get to the point where they're launching New Glenn, the bigger rocket, heavy rocket that can really go into space and send things into orbit, I think at that point, if they're able to have complete success with safety for sending humans up with New Shepard, the technology scales, right? They're going to use the same technology from New Shepard to New Glenn, and then that's going to allow them to basically come out with a rocket that can send humans around space or into space and build their space station orbital reef. And by that point, they'll have captured the trust that I think we have with regular, aerospace or flying a commercial airliner. People just jump on those things now. We may get to that point in the future, but the question is, are you guys riveted by this? Are you really excited about these Blue Origin missions, or is there something else that's capturing attention? So let me know. Hit us up at Today in Space Pod. Email us at todayinspacepodcast@gmail.com. And, of course, on Twitter at Today in Space Pod. Let me know. Next up, we've got to talk about the moon soil plants. So let's break it down a little bit and talk about some of the specifics. I'm going to go into the article that was released on May 12th from NASA, and then I'm going to touch on a few things and give my outlook of why I think this, what is it about this test of growing plants in lunar soil? How is this going to change the future? So, NASA-funded study breaks new ground in plant research. In the early days of the space age, the Apollo astronauts took part in a visionary plan, bring samples of the lunar surface material, known as regolith, back to Earth where they could be studied with state-of-the-art equipment and saved for future research not yet imagined. Bring us to today, 50 years later, at the dawn of the Artemis era, and the next astronaut returned to the moon, first woman and person of color. The 3 of those samples have been used to successfully grow plants. So for the first time ever, researchers have grown the hardy and well-studied Arabidopsis thaliana. I'm actually surprised at how well I said that. In the nutrient-poor Lunar Regolith. Now, I did look up Arabidopsis thaliana. It's essentially a weed, which is interesting too, because if you know how pervasive weeds can be on Earth, you would expect that something like a weed would be one of the things to survive, like a cockroach, right, on the moon. So I think it's a very interesting thing. It also has a lot of features of plants that we want to grow so that you can have a baseline, plant one in regular Earth soil and then plant one in lunar soil and see how those different things grow and how long they last. They said here, this research is critical to NASA's long-term human exploration goals, as we'll need to use resources found on the Moon and Mars to develop food sources for future astronauts living and operating in deep space. That was from NASA Administrator Bill Nelson. This fundamental plant growth research is also a key example of how NASA is working to unlock agricultural innovations that could help us understand how plants might overcome stressful conditions in food-scarce areas here on Earth. A very good, see, this is why Bill Nelson is the NASA administrator. He knows how to sell. He knows how to sell space. He gives the Earth example. I love that. But it's a really interesting idea, right? So I think originally, before this happened, I think even myself, I held this opinion, that we all saw The Martian. We all saw Mark Watney grow plants on Mars. And it was like, oh, it's because he's a botanist that the plants grew in the first place. But it seems that you could probably grow plants in a lot of different soil. The question is, how long will they survive? And if they do survive, how much nutrients are you actually getting from that thing? And how much has it changed having to adapt to the soil that it's not used to growing in? I think that is a huge change. Now this shows the populace that growing plants on the moon is possible. Granted, we need to develop some techniques. We need to figure out how to make this work, but it's a really big first step. I don't think it blows, and an article we'll have here as well from ARS Technica by John Timmer. Basically, they're saying there that this is not groundbreaking by any means, but it at least sets up the groundwork for future research, for more development and money to get it actually done. So it says here in this article to grow the Arabidopsis. There we go. The team used samples collected on the Apollo 11, 12, and 17 missions, with only a gram of regolith allotted for each plant. The team added water and then seeds to the samples. Then they put the trays into terrarium boxes in a clean room. A nutrient solution was added daily. After 2 days, they started to sprout, said Annalisa Paul, who is also a professor of horticultural sciences at the University of Florida, who is the first author on the paper. Everything sprouted. I can't tell you how astonished we were. See? It was even surprising to them. Every plant, whether in lunar sample or in a control, looked the same up until about day 6. At day 6, however, it was clear that the plants were not as robust as the control group of plants growing in volcanic ash, and the plants were growing differently depending on which type of sample they were in. The plants grew more slowly and had stunted roots. Additionally, some had stunted leaves and sported reddish pigmentation. After 20 days, just before the plants started to flower, the team harvested the plants, ground them up, and studied the RNA. In a biological system, genes are decoded in multiple steps. First, the genes, or DNA, are transcribed into RNA. Then, the RNA is translated into a protein sequence. These proteins are responsible for carrying out many of the biological processes in a living organism. Sequencing the RNA revealed that the patterns of genes that were expressed, which showed that the plants were indeed under stress and had reacted the way researchers have seen Arabidopsis respond to growth in other harsh environments, such as when soil has too much salt or heavy metals. So it's kind of a, for me, it's a message that stress is not good, whether you're a plant or a human being or whatever you are. So, and it's an interesting metaphorical example too, where it's like even your environment can be stressful. And I know that seems obvious, but it's a good lesson. It's less about whether something is possible and more about, are you able to have a good mindset about it? Are you able to go about it a good way? How much that has a big effect on how you are as a person. But as far as plants go, because that's exactly what we're talking about here, it's a major breakthrough because it shows us that growing plants on other planets and other soil around the galaxy seems to be something that we may be, not only are we able to plant things, but now the game is on to figure out how do you make these extremely stressful environments less stressful, promote growth in the areas that we want to, right? You'd want to make sure, we have specifics now, right? The plants grew more slowly, so you probably want to try and increase how much they grew. The stunted roots, that's not great. That means they're less sturdy and they're not able to get as much nutrients, as far as I understand. And stunted leaves and the reddish pigmentation is an interesting thing. Is the reddish pigmentation a sign of stress? Is it a sign of something else? Does that mean that we may have lunar plants that are mostly red? Like, that would be really interesting, right? If different plants grow in different places, you may be able to increase the nutrients, but the color and the look, something about that may change. What we'll find out over time as this gets worked on, but it's some interesting things to think about of now that we have some details, how do you think about this differently? I love this kind of science where we've got this held idea that we've all thought you can't grow plants somewhere else, and then we're able to do it, and then we go, whoa, interesting. Like, let me learn more about this. So I thought it was an amazing story. This is John Timmer's. I'll talk about just this first thing that he talks about, and I'll leave the rest for you to go and read, because it is a really good article. It says, this is the final section of what this tells us. There are a couple of ways to look at these results. The first is that the study represented a serious stress test. While the samples were watered using a nutrient solution, they were dumped into Lunar Regolith as is, no mixing with organic material, and no microbial growth that could sequester some of the metallic toxins before the plants encountered them. So the experimental setup made things harder than they needed to be. So, to his point, there's so many things that we didn't do that we could try. Maybe there's a combination of Earth soil and lunar soil that, if we're going to go grow stuff on the moon, we figure out how much we need, and then we get like a blend of this. And as he said, which is such an interesting point, like maybe there is some microbes, getting a microbiome to go along with these plants like we have here on Earth. We take it for granted, but we have it here on Earth, that do so many little things to make the environment less stressful, and take care of some of the things like the metallic toxins that are going to be most likely involved in most soil that we're going to be experiencing out in space, and probably in amounts that we've never seen before. So really, really interesting result that was shared on May 12th. And the other, which was also mind-blowing and in a completely different other direction, was that astronomers revealed the first image of the black hole at the heart of our galaxy. This one really blew me away, and the Event Horizon Telescope .org, this is where we're sharing this. This is the article that got shared, but it's the Event Horizon Telescope really has shown us some crazy stuff. So I'm going to start at the top here. Astronomers have unveiled the first image of the supermassive black hole at the center of our Milky Way galaxy. This result provides overwhelming evidence that the object is indeed a black hole and yields valuable clues about the workings of such giants, which are thought to reside at the center of most galaxies. The image was produced by a global research team called the Event Horizon Telescope Collaboration, using observations from a worldwide network of radio telescopes. This image is a long anticipated look at the massive object that sits at the very center of our galaxy. We've seen, scientists have seen stars orbiting around something invisible, compact and very massive at the center of the Milky Way galaxy. But this is like the first time we actually have seen it. And so Sagittarius A, which now we know is a black hole, is the first visual evidence. And it's pretty cool because this not only showed us that there is a black hole, but it proves Einstein right again. And to think that Einstein gets a second shot after death to prove he was right through an image, right? That's how general relativity was proven, showing the curvature of space and light around the moon during an eclipse, and seeing that the position of that star moved that was coming out from behind it, showing that the moon's mass is in fact warping the space around it. At the same time, we have now shown through an image, which is crazy to think of, right? Because it's a black hole. You can't see it, so you need to have things that it has either bending around from behind, that you're seeing from behind it and seeing a ring. But these rings, I'm gonna let's this paragraph before has actually a good explanation. So black holes themselves can't be seen, completely dark, but the glowing gas around reveals a telltale signature. The shadow surrounded by a bright ring-like structure. And so the view that we got showed the light bend from the power of gravity from the black hole, which is 4 million times more massive than our sun. So let me repeat that. So that thing that we can't see, that is the center of our galaxy, is probably the whole reason why we even have a galaxy in the first place, has 4 million times more mass than our sun. And we've only just seen a picture of it today. The black hole is 27,000 light years away from Earth, so don't worry too much about there being one. And appears to be about the same size in the sky as a donut on the moon. So it's an interesting... That's an interesting thing. So really far away and really hard to see. The team had to create an EHT, Event Horizon Telescope, which linked together 8 existing radio observatories across the planet to form a single Earth-sized virtual telescope. And it observed Sagittarius A on multiple nights, collecting data for many, many hours in a row, and using basically like long exposure time on a camera. So in 2019, they actually took the first image of a black hole, M87, at the center of Messier 87, which is a galaxy. And I remember that one, that picture was kind of wild as well. And they look pretty similar, which is really crazy. But they are 2 different types of galaxies, and they have 2 different black hole masses, which is very interesting. So according to Sarah Markov, the co-chair of the EHT Council and a professor of theoretical astrophysics at the University of Amsterdam in the Netherlands, this tells us that general relativity governs these objects up close, and any differences we see further away must be due to the differences in the material that surrounds the black hole. All right, so some stats here. Just like let's talk about the gas that's helping form this ring, right? Comparing the 2 black holes, right? M87 and Sagittarius A. The black holes move at the same speed, nearly as fast as light. This is the gas around Sagittarius A and M87. But where the gas takes days to weeks to orbit the larger black hole M87, the smaller black hole, Sagittarius A, it completes an orbit in mere minutes around that thing. This means that the brightness and the pattern of the gas around Sagittarius A was changing rapidly as the EHT collaboration was observing it. And they say here it's like trying to take a clear picture of a puppy quickly chasing its tail. So part of the reason why that ring is so blurry is because that gas is moving so fast, which is just absolutely crazy. The fact that we were able to see this thing is only because we had something behind it to help show that this giant invisible thing is at the center of our galaxy. And I think it's one of the coolest things we've seen. And to segue into our next topic, James Webb Space Telescope is going to be helping us figure out the early creation of black holes, galaxies, because now we can see there some clear correlations here going on. How did they develop? How were they created? And having 2 black holes where we know where they are to be able to observe with something like James Webb Space Telescope, the timing of it is just insane, and it's really looking forward to that. To close out, let's talk about James Webb Space Telescope. So, July 12th, NASA is planning to reveal the first images from NASA's James Webb Space Telescope. So as it says here, NASA James Webb Space Telescope, a partnership with ESA, the European Space Agency, and the Canadian Space Agency, CSA, will release its first full-color images and spectroscopic data on July 12th, 2020. As the largest and most complex observatory ever launched in space, Webb has been going through a 6-month period of preparation before it can begin science work, calibrating its instruments to its space environment and aligning its mirrors, which we've talked about a lot here on the podcast. And we actually had one of the animations from the NASA team on like how that actually happened and how crazy it is. This careful process, not to mention years, decades, of new technology development and mission planning, has built up to the first images and data demonstration of Webb at its full power, ready to begin its science mission and unfold the infrared universe. And this is a quote here from Eric Smith, the Webb program scientist at NASA headquarters in Washington. As we near the end of preparing the observatory for science, we are on the precipice of an incredibly exciting period of discovery about our universe. The release of Webb's first full-color images will offer a unique moment for us all to stop and marvel at a view humanity has never seen before. These images will be the culmination of decades of dedication, talent, and dreams, but they will just be the beginning, and that can't be said any better. It really will be the beginning, but I'm really looking forward to what we're going to see here. It says here, there are things that they're expecting and hoping to see with this first image, but with the new telescope and this new high-resolution infrared data, we just won't know until we see it. That was by Joseph De Pasquale. Early alignment imagery has already demonstrated the unprecedented sharpness of Webb's infrared view. Now the big thing that James Webb Space Telescope needs to do is survive long enough for us to get good images. And the reason I say that, and we talked about it earlier in the episode, we found out recently, I think it was actually today, that James Webb Space Telescope actually suffered the first noticeable micrometeoroid impact on May 23rd and May 25th. And apparently the C3 panel segment on the 18-piece hexagonal primary mirror was the one that was affected. The good thing is that the spacecraft was literally designed and expected to experience this kind of thing. The big sun shield that you see that blocks that's behind the telescope is actually built specifically to dissipate the force of these kind of micrometeoroid impacts. Of course, if it hits a panel, that's a different thing, but part of the reason for the 18 individual segments is to allow the telescope to have these redundancies, which I think is I hadn't really considered that these 18 panels are actually redundancies. And, if 1, 2, 5, it seems, go out, you may have some pockets and you might lose a little bit, degrade some of the data that you're getting, but you're still able to have that telescope work. And we know that James Webb Space Telescope isn't going to last forever. We know that there is an end of life because it does need some fuel to keep up its orbit at Lagrange Point 2, but it requires really little fuel, and we were lucky enough that the Ariane 5 rocket that launched James Webb Space Telescope into space did it so well that they actually didn't have to use as much fuel, which actually gave more life to the telescope while it was there. So it's a little scary that a micrometeoroid already impacted a mirror, but they did expect micrometeoroid impacts, as they say, would gracefully degrade telescope performance over time. As with Lee Feinberg, Webb Optical Telescope Element Manager at NASA's Goddard Space Flight Center in Maryland. Since launch, they've had 4 smaller measurable micrometeoroid strikes that were consistent with expectations, and this one more recently that is larger than our degradation predictions assumed. So it's a nice reminder that even though it is the vacuum of space and it is the dark void, it's not empty, and there's a lot of stuff out there, and it's something to keep in mind for the future as we start sending humans out there. We don't have human redundancies. At least that's not how we do our space programs. So something to think about. Space weather is a crazy, crazy thing. We'll have to do an episode on that. I'll have to bring our brother on here, and we'll have to talk about that. But that's a little update. I'm looking at this. It was literally published 4 hours ago from the time we recorded this. So I am glad that James Webb Space Telescope is still working. I'm really looking forward to those images. And talking about the images, let's go to our final topic here. I was able to ask a question on the NASA Twitter Spaces for the James Webb Space Telescope team. They had a bunch of the team on to answer questions, to discuss what was going on with James Webb Space Telescope, and I asked a question about the data that we're getting from these telescope images. You know, we have the Hubble images, and they were able to transfer that data back, and those images alone have kind of transformed how we all think of space. They're on all of our screen savers. Hubble has done some amazing things, and now with James Webb Space Telescope, there's so much data that we're getting from this. There's so much in just the alignment process that was needed, but also in the data that we're getting, and it's bigger. Like, there's a lot more data, which means the file's bigger. How are they getting it back to Earth? And all those different questions and how different it is. We were really lucky to ask a question, and then it spurred this moment with a bunch of other questions from folks asking online. I thought it was beautiful. I want to share that here. And of course, take a look for that NASA wave. By the NASA account when I asked my question, still blowing my mind. But we'll close out with that. Thank you for joining us on Today in Space. Have a great week, and we'll be back for another episode of Today in Space. Don't forget AG3D Printing for all your 3D printing needs, and help support the podcast, ag3dprinting.etsy.com. Follow us on Today in Space Pod, AG3D Printing on Instagram, Today in Space on TikTok. Have a great week, everybody.
So let's take a question from Philip, or PVS 713. If someone is given time to use Webb, do they get to control the telescope as well as the images and the data as they come in? Or are there engineers and other people who operate Webb and then give the images and data to the scientists who requested it? Oh, that's really interesting. Yeah, let's learn a little bit about, these people who have proposed to look at different objects with Webb. Are they actually controlling the telescope? Maybe, Tim, do you want to take that one?
Sure. So when an astronomer knows what they want to observe, they put in a proposal, and it's actually a completely free process where a committee, the community in effect, chooses the proposals which are then selected and a telescope. And in that proposal process, the astronomer defines everything. So where the telescope will point, which instrument is used, the configuration of the instrument, so they can really fine tune everything for the best science that they would like on the objects that they would like to see. So in effect, they are controlling the telescope, not physically in real time when we're looking at the objects, but they do define everything themselves during the proposal process.
Very cool. And actually, at this moment, I'm at the Space Telescope Science Institute in Baltimore, where actually there is a huge team of people literally controlling the telescope, people literally responsible for pushing buttons to send commands to the spacecraft. It was very cool to meet some of them earlier today. And if you stay tuned to our NASA Webb social accounts, you can learn more about mission operations next month. So let's see if we can get a live question in. Alex G. Orphanos, or ELGR3CO. Let's see, can you unmute yourself and ask your question?
Hey, everybody. This is Alex from Today in Space. Thanks for getting my question. I was looking at, you guys have an amazing page with graphical animations of the process of dialing in the mirrors for James Webb, and it really got me thinking about how much data each image James Webb is taking. Is there anything that really you think that people should know about how different the data is each image that we're getting back is compared to something like Hubble, how far the technology has come? Thank you.
Thank you. That's a great question. Jillian, do you have thoughts on that?
Well, of course, one thing for Mary is that we have these super sensitive mid-infrared detectors, and they've never been on Hubble. So it's looking at the universe in an entirely different way with those detectors. Our detectors are quite small, though, because it's so much harder to make mid-infrared detectors, and we've only got 3 of them. So in some ways, our images will not cover as big an area as a Hubble image will, but they will be really unique because they're looking in the mid-infrared wavelengths.
Awesome. And Marcia, did you want to add anything about NIRCam and how its data is different from other telescopes?
Sure. And with the largest number of pixels on Webb and a larger number of pixels than any of the cameras on Hubble, I'm sometimes called the pixel pig. And if you use NearCam, it really takes all the bandwidth almost for sending data back to the ground. And so our data files are very large, partly because of the large number of pixels, partly because of the way we take the data, which has been used on the infrared camera on Hubble, which is much smaller, but we save all the readouts. And so if we expose for 1,000 seconds, we might send 10 different images to the ground for that 1,000 seconds, each one of which is separated by 100 seconds from the previous. And we do it at 2 wavelengths. And so this totes up to a lot of data coming down at once. But the archive has already demonstrated that it can ingest this and make it available, at least right now, to those of us that have to analyze the test images.
Very cool. Well, let's see if we can get another live question. This is from Mux Harris. I think you're able to unmute yourself. Mux Harris, are you able to unmute yourself?
Hey, this is Haris from Pakistan. I have a basic question. Will we be colorizing the Webb images like we used to do Martian images? Is it even possible with infrared cameras?
Thank you so much. That's a great question about how the images will look. Will they be sort of artificially or naturally colored? Let's see. I think I'll go to Renee first.
Yeah, well, it's a very good question. So when we get our images, there's a lot of artifacts that we need to correct. So there's a lot of image processing that has to go on. So these force systems are really complex machines. But what is not fully appreciated sometimes is that the data processing of these images and data are actually quite a lot of work. So the images you're going to see early July, which will be extremely beautiful, are a lot more beautiful than the raw image that we're going to have. But it's part of the process that we need to process these images. And I just want to come back to a point of the previous question about the data flow, which it's this huge amount of data that we have to transfer from the 1.5 million kilometers. Just to give you an idea of the data flow, it's like the data rate is similar to an LTE network. So Webb is equivalent to have an LTE network at 1.5 million kilometers away. So it's not bad.
Wow, LTE service at 1 million miles away. That is very powerful. Marcia, would you like to add something?
Yeah, since our eyes aren't sensitive to the infrared, if we make an image to show what we found, we have to inject some color interpretation. And if you think of the images and spectra that come from Webb, they're like a digital camera image, but we get to assign somewhat arbitrarily who's red, who's green, who's blue, and so on. And sometimes we do that to highlight a particular feature in the image. And so we'll see how these, what should properly be called false color images, because our eyes can't see the infrared.
Thank you. Yeah, so these images will look spectacular. Webb is really our infrared eyes on the universe, since our eyes cannot process these images. That's why we have this amazing telescope to do so. And rest assured, there will be some coloration, but it will be applied kind of after the fact to highlight certain features. So let's go to a question from Twitter from Ty. Will you be observing the TRAPPIST-1 system? And if so, what will Webb be able to tell you about the planets that previous telescopes could not? I'm going to start with Jillian. Would you like to talk about the TRAPPIST-1 exoplanets?
Well, we will be looking at one of the TRAPPIST exoplanets, TRAPPIST-1b, and our interest is to look at the atmosphere or try and detect features coming from it with the spectroscopy, so that we can look at maybe what kinds of things are in there. But Rene is much more of an exoplanets expert than I am, so I think we should ask him.
Well, the TRAPPIST-1 system is the rock star of exoplanet, right? This is the TRAPPIST-1 is a very small star. It's not much bigger than Jupiter in our known solar system, and there's 7 planets that goes around this star, and they happens from our perspective to transit. So the every 7 planet goes in front of the star, and they're just blinking at us. And so what we want to do with Webb is answer the. So all these planets have about the same size and mass as the Earth, and we think that 3 of them are in the so-called habitable zone. So not too close, not too far from the star, so that we can hope to have maybe liquid water at the surface of these planets. So, but what we don't know about these planets, what are they made of? Do they have an atmosphere? Do they have water? Maybe some of these planets are water worlds, rocky core covered by oceans. And that is the big questions that Webb will try to answer. Do these planets have an atmosphere? In fact, all science instruments will look at these planets very eagerly. And in fact, the very first data that will come from Webb on transiting exoplanet will actually TRAPPIST-1. By mid-July, we'll have quite a lot of data on the TRAPPIST-1 system with NIRSPEC and the nearest instrument, and later on with MIRI. So it's very exciting. So very early on, we'll have data from the TRAPPIST-1 system.